In this video, I'm going to be looking at using what's called the pipe operator. Now, using the pipe has become a very common way of entering complicated code into R. It enables you to use functions upon functions in a way which is much more readable than the standard approach. Now, the pipe operator is available in a package called magrittr, or M-A-G-R-I-T-T-R, this package here, which if you're not going to be using tidyverse functions, then you need to load that up into memory. But if you're in the tidyverse, then it's automatically built in. So I'm first of all, in fact, going to load up the tidyverse. Then I'll read in some data, and I'm going to read in this small data set that I've been using on a number of occasions. So reading it into a tibble. It's this data, of course, showing usage of particular social media sites by a sample of 20 men and women. So we've got these three variables: gender, site, and usage hours per week. Now what I'm going to illustrate is I'm going to show how to draw a graph, a bar chart, of the number of users of each particular site. So I'm going to create a frequency distribution by site and then plot that. Now I think I've drawn this graph in a previous video, either the one I think in one of the ggplot2 videos, and I'm first going to look at how I did it there. Now, one way in which you can do this, draw this graph, is to use intermediate objects. That is, first of all, create the grouping with the group underscore by function, which I've looked at previously, and then store the results in grp. Then find the count of the grouping, in other words, count how many values in each of the groups being the sites, and store that frequency distribution in this variable freq underscore site, and then finally use that grouping, that frequency distribution, in ggplot in order to draw the graph. And this used to be quite a common way of doing it, and still is used. So let me show that. So I'm creating the grouping. Remember, as I said in the tidyverse, this doesn't actually create the frequency distribution of such. It just creates a grouping which you can then use to create a frequency distribution with the count. And then I can, in fact, let me just show that particular grouping that I've created. So there it is, of course. I've created this frequency distribution of site. So of these 20 cases, 7 used Facebook, 5 Pinterest, and 8 Twitter. And then if I want to draw this as a bar chart, of course I can use ggplot using geom underscore bar. I've covered all of this in the videos on ggplot2. Site is, of course, the x variable, and n is the y variable, the frequencies. So using a familiar command, I haven't put any of the extra stuff here you'd put up for titles and so on, just because I just want to show the basic chart. And there it is. So that's certainly one way in which you could create this chart. Another way, of course, which involves less lines of code, is to put functions inside functions. You can, of course, in R do this. You can have a function which takes as its argument the output of another function, and in fact you can go a number of any levels deep. The problem with doing this, however, is of course that it involves lots of brackets, particularly if you start going into 3 or 4 levels, which of course is prone therefore to syntax errors, missing off brackets, and is actually not very readable in terms of seeing what it's done. But let me show how I could do this here. So as you can see, rather than doing these two lines separately here, creating the grouping and storing it in GRP and then putting GRP into count, I could combine those by putting inside count this code here, the group by function. So I put the group by function inside of count. So of course things work from inside out. Of course it creates the grouping, which is then becomes the input to the count function. So I've effectively combined these two lines here, 6 and 7, into a single line. And then of course I run ggplot on as before, the same line as line 9, to get of course the same graph. In fact, what you could do of course is go further. You could combine all 3 lines here, or 4 lines I should say. Sorry, that number 8 there was just printing out the grouping. So I could combine lines 6, 7, 9 into a single line of code here by putting a function inside a function inside a function. So as you can see, I've taken this code here and put it inside which created that, rather than storing that in an intermediate object, freak underscore site. I put it directly into ggplot. So we end up with just one line of code here. And this of course will do the same thing. But as you can see, what could happen here is if you're not careful, you're going to miss off some brackets. It's involving lots of brackets here which have to be in the right order and they have to match up, otherwise you'll get a syntax error. So running that, of course we get exactly the same. So here we're using functions inside functions, and of course it could be any level deep. Now this way involves lots of separate lines. This way I only had one line, but it's quite complicated and it's not it may not be immediately obvious what you're trying to do here. The pipe operator is another way of doing this, which gives you a way of seeing exactly what's going on. Now the pipe operator is this thing here, percentage greater than percentage. In fact there's a keyboard shortcut to put that in, which is Shift Command M. That's on the Mac. It'll be Shift Control M on Windows. And the way to read this pipe operator is to read it as the word then. Now remember we read the assignment operator as gets. A way to think of this is then, because what it's saying is that you do this, then you do this, then you do this, and so on. So what I've done here is I've taken my tibble, then I've grouped by site. Now notice that here I didn't need to put pract tb in as I did up here, because what the pipe operator does is to effectively use the output of this function here, which in this case is just pract tb itself, as the input. Notice in every function in R the first input is some particular object. Now group by needs a tibble as its object, and that's what it's getting here by using the pipe operator. So having grouped by site, I then count that grouping. So again notice that the count operator, which needs an object, a grouping, takes this as its object, and then you plot count, just as we did, you plot what the count is, which of course previously was in a variable, but now it just gets passed on. So as you can see, what we do here is you basically do it in stages by saying do this, then this, then this, and each piece of each function here takes as its input the output of the previous one. So this will take, this group by will use pract tb as its input, which is what I want. Count will use the output of this thing, which is what I want, and then ggplot will use the output of this thing, which is what I want. So it's effectively doing the same as this line here, 15, but in a much neater way where it's easy to see the stages that you're going through. So I think you can see why that is becoming a popular way of showing the code. It's much more readable. You can see what you're doing step by step. And as you'll see, if we run that, we'll get exactly the same graph. So that illustrates how we use the pipe. Instead of using intermediate objects or functions inside functions, then using the pipe means you can set up the code and the operations you want to carry out in a sense step by step. You start off with the first function, then you go into the next one, and the next one uses the output of the first one, and then the next one, and that uses the output of the previous one, and so on. So you don't need to, in these functions, I didn't need to put some object because it takes as the first argument, which you normally do, because it takes the output of the previous one as the input. Now, just one other thing that is worth looking at in the use of the pipe. That function, magit_tr, was it magrit_tr, which contains the pipe, which notice I didn't have to explicitly load here because it's built into the tidyverse, has a number of other pipe operators. This is the main one, but there's another one that's in there is called the T pipe. And what this does is to take not the input, the output of the previous function, but it will take the input. And sometimes you need this. If a particular function that you're going to use doesn't have an output, then the next step won't work because there's nothing for it to take. To see this, look at what I'm doing here. I'm taking the usage variable from practb, and remember we saw in the tidyverse video how to access one particular variable here using the dollar notation, rather like a list. So I'm taking the usage per hour variable. Let me just go back, which of course is this one, which I'm then going to plot, and then I want to find the mean of that. Now, the problem with what I'm using the pipe here is that this first stage will work because plot will use usage HPW, use the output of this command, which is the variable I want to plot. But plot itself does not have any output, which can be used as the input to mean, because what I'm wanting to use as the input to mean is pract usage HPW. So see what happens when I run it as it stands. Okay, we get the graph all right. It's plotted those usage that variable, the values in that variable, usage HPW, which is a very simple graph, but it hasn't found the mean, because as it says, the argument that mean is taking, which is from plot, it just doesn't work. Now, the way around this, let me just clear this and so you can see it better rather than at the bottom. In fact, let me just run that again so you see exactly that it didn't work. Okay. Now, the way to solve this is to use this T pipe here rather than the standard pipe. And what this basically says is it tells plot to return the input to the plot function rather than the output. And the input, of course, was this variable, which is what I want. So this will take this variable, plot it, which is what I want. It will then pass on to the mean function, not its output, but its input, which is this one, which of course is exactly what I want. Then the mean will find the mean of this variable, of the usage variable. So let's see if this works. And there we are. You can see that it did. So again, I get the plot, but then I do get the mean of this variable. When I use this, I didn't, because mean used the output of plot, which is no good, but now mean uses the input of plot, which is this, which is correct, and so the mean is 31.95. So that covers the basics of using the pipe operator. Now, if you want more information, then I recommend going to the book by Hadley Wickham and Garrett Grolemund, a book I've mentioned before as being the standard work on the tidyverse. It's called Alpha Data Science, and you can find it at this address. Now, you'll find if you look under the table of contents here, scroll down, there is a section on pipes, there it is, which contains the sort of information that I've gone through myself, plus other stuff. So if you want a written explanation here, you'll find this. But also I do recommend looking at this section here. If I can get to it, there we go. Section 18.3, when not to use the pipe, because there are circumstances where it's not advisable to use the pipe and to use one of the other methods that I've looked at. So it's well worth looking at that section.